cover where PowerMill Robot's strengths lie. We'll also talk about some examples of PowerMill Robot, so artistic carving and sculpting, through to high-end engineering applications for aerospace. And then we're going to look at the future of parts on demand, which is like services for robots on the cloud. So PowerMill's strengths really lie in very complex machining of geometries and complex tasks, not so much on pick and place or these traditional welding techniques, but more complex examples like you see on the far right hand side. So throughout my presentation, I'm not going to make you listen to me too much. We've got plenty of videos for us to show you. And the first one of these is to do with sculpture. So PowerMill Robot has been used in artistic sculpture. And it's not really about replacing artists as such. It's really about just doing all of the grunt work up front for the artist, and then they come in and do the fine details at the end. So from high-end art, where you're seeing a robot as a colleague rather than replacing you, to other applications in engineering, such as high-end aerospace projects. So in a typical aerospace engine, you're going to see thousands of blades, all of which could be slightly different from one another, all of which need polishing as well. This is long and laborious, and I actually come from aerospace. I used to know a lot of guys who got really bad like carpal tunnel or things like that from standing all day polishing these blades. And this is another great use for robotics, where we can replace that manual work and free those guys up to do different tasks. So now they could be programming a robot as opposed to stood all day polishing. Another high-end use for robotics is the introduction of additive in robotics. So I'm sure some of you have seen the example over there that we have from the Port of Rotterdam. Port of Rotterdam is the third largest port in the world, and they have ships coming in and out all day, every day. And if a ship is damaged, or the propeller on that ship is damaged, it can be waiting at port, and you can be waiting weeks for a replacement part that's cast. Now we can replace that casting with a additively manufactured part, and we use robots to drive this additive manufacturing process and lay down weld quickly in areas where we need to. This has resulted in the world's first certified marine propeller. It was certified by Bureau Veritas earlier on this year. And there's a short video on how we collaborated with RamLab and the Port of Rotterdam to create it.
This is a Damen Stern-Tug 1606 workboat. Many have come before it, and this will certainly not be the last. Still, this one is special, not because of what you see above the water, but because of what happens below the water. This vessel is propelled by the PowerMill, the first class-approved 3D printed propeller. This project took 7 months to complete and brought together key players from different industries, all with the same goal: to manufacture and certify the world's first wire arc additive manufactured propeller. The starting point of the project was a propeller designed by ProBusiness. Before it could be sent to the 3D printer, the design first had to be transformed into a so-called CAM strategy, a detailed plan of how the printing of the complex double-curved geometry of the propeller blades should be carried out. This strategy was thought out by Autodesk with the use of their PowerMill software application. Meanwhile, specialists at RamLab in Rotterdam started on tests to ensure the PowerMill would be strong enough for the job. Through different material tests and prototypes, the building strategy was finalized. In September of 2017, everything was set to start the production. By printing a total of 2.6 kilometers of nickel aluminium bronze in 298 layers, RamLab created the PowerMill in one go over just a few days, printing around the clock. With advanced 3D scanning methods, the propeller was checked and finished by ProBusiness and deemed ready for testing. For the last stage of the project, the PowerMill was brought to Damen shipyards in Gorkum, where it was installed on the Stern-Tug 1606. What followed was a stringent trial program, including bore-out pulling and crash stops. These trials turned out to be a big success. Shortly after, the PowerMill received its class approval from Bureau Veritas, making it the world's first class-approved 3D printed ship's propeller, leading the way to a future where 3D printed metal parts for the maritime sector will be business as usual.
So some of you with a keen eye in that video, you'll have noticed that we did all of the 3D printing with robots, and then they thought it was perhaps a step too far, too advanced for them to then finish it with a robot, so you saw a guy hand grinding the weld back. Yeah, maybe that was a step too far, then done the welding with robots, do the other, the traditional way. So one of the last topics I want to talk about is robots on the cloud. And this is where we had a collaboration with a company called Candy Mechanics. And this was really to componentize some of the functionality that's in PowerMill and make it available on our Forge platform for anyone to then go away and make their own microservices. So like I said, it was between us, Candy Mechanics and ABB were the people working on this. So they wanted to create like a configurable microservice. Candy Mechanics, they'll scan your face and make a chocolate bar out of your face, or you can do like custom greeting cards out of chocolate. So yeah, we did something special for them. So using our huge monolithic piece of software, which is PowerMill, we broke it all up into components, and then we put the code for each one of those components onto the Forge platform. Putting it on the platform then allows us to create an app. This app can then be used on any device. So anything that has a browser, you can access PowerMill's functionality through it using Forge. And in this case, we actually had the robot at our facility in Birmingham, and you could go up to the machine, type in whatever you wanted to have on your greeting card. It would go away, it would call the functionality from PowerMill that was hosted on Forge, turn the lettering into toolpaths, and then turn that toolpath into robot movement and post it to the robot. So here you can see it in action here. So there you go, the text is being converted, then it's passed through a robot kinematic solver and posted out to the robot. We actually use Fusion Production as well. So we posted it out to Fusion Production, and that allowed us to have another browser-based interface where we just press start and it starts the robot off machining. So this is really where we're looking at going moving forward. So componentizing some of the functionality in PowerMill and making it available on Forge so that you can create these microservices. So that's the end of my presentation on robotics. If you guys have any questions, I would be more than happy to answer them.